Hi, welcome to our Cybil Consult channel. Myself is Mohammed, and today I'm gonna uh, tell you briefly that how we can design a sprinkler system for a residential building. So, uh, going through this short video or lecture, I will try to highlight that what kind of parameters you need to take care of while designing a system where sprinklers type is residential, because residential sprinklers are those, as you can see on my screen, a type of fast response sprinkler having a thermal element with an RTI of 50 or less, and that has been specifically investigated for its ability to enhance the serviceability in the room of flood origin, and that is listed for use in protection of dwelling units. So on the left side, you can uh, you can see that I have tried to model an apartment. This is a sprinkler main in green colors coming to an apartment, and from that cross main, these are two branch lines going into three different rooms of the apartment. So first of all, as per NFPA 13, Chapter 11, if you go to special design approaches and the clause 11.3.1, the clause of residential sprinkler has been defined, and the purpose of this training video is to let you know that what kind of things you need to take care of, and sometimes it's not easy for newbies to develop an understanding that how a residential sprinkler system should be designed. So first thing you will do is go to the clause 11.3.1, which says that the design area shall be the area that includes the four adjacent sprinklers that produce the greatest hydraulic demand. Uh, let's suppose this is a building I'm talking about, maybe 5 or 6 story building, and the apartment on the one side of the building, which is hydraulically most disadvantaged, is in our apartment for which we will design a system. And once we can design a system for this apartment, uh, it can be make sure that all the apartments of our buildings are safe. You can say that discharge rates to all other apartments will be sufficient to extinguish the fire in case of fire. So first step is to design is to mark the design area, and you can see that design area should be an area under four sprinklers. And in my example, these are the four sprinklers: one, two, sorry, two, three, and four. So these four sprinklers under consideration mark and design area. So once the design is defined, next step is to make sure that there is no ceiling space around, uh, which has been defined as a combustible ceiling spaces as per clause 1815.1.2 and 1815.6. And these ceilings above our rooms are not combustible ceilings, and all those ceiling areas does not need protection from fire. So next step is to make sure that what kind of sprinklers you are using for your particular project. It's very important to have some sort of information in hand before you design a system, or if you have been asked by an owner of the building to design a system for you. So first of all, you need to make sure that you have data in hand, the sprinklers you're going to propose. So there are two options. One, you can propose sprinklers, listed sprinklers, or another option is that you can request the information from the building owner to let you know that who is a vendor of sprinklers, who's going to sprinklers, and you can request at least these four or five things from the designer, that what is the who is the manufacturer, and what will be the K factor and area of sprinklers and discharge pressure of the sprinklers. Like in my case, I have chosen a manufacturer is Viking, K factor is 4.8, area of coverage by that sprinkler is 250 square foot, and discharge pressure for this sprinkler listed sprinkler is 9.7 psi. As you may well aware that the minimum required pressure, discharge pressure for the sprinklers as per NFPA 13 is 7 psi, but in our case, the listed sprinklers design pressure is 9.7 psi. So once the sprinkler has been chosen, a design area has been marked. Next step is you have to make sure that the required discharge from each of these sprinklers in this design area shall be greater of. So there are uh, three different parameters you need to comply with. Uh, you cannot simply say that okay, uh, areas chosen sprinkler class has been identified and let's go, but you have to make sure, as per clause 11.3.1.3 of NFPA 13, that the minimum flow rate indicated in the sprinkler. So thing is, we need to make sure that in this design area, which we have chosen, in my case, design area is 517 square foot. So in this design area, the discharge from each of these sprinklers, like in my case, four sprinklers, and each of those four sprinklers shall have a discharge which would be greater of these three options. So option one is that in accordance with the minimum flow rate indicated in the sprinkler listing. So in the sprinkler listing, they will provide you the information of K factor and design discharge pressure. So as I did, the step number one is that design area for just sprinklers. Step number two is determine the larger of discharge rate for these four sprinklers. So as per listing, each sprinkler can discharge Q is K into E square root of pressure, which is, you can say that 5.6 multiplied by 9.7, so 17.4 GPM. So if all of these sprinklers are going to operate at a minimum discharge pressure of 9.7 psi, so each of these sprinklers will give you discharge of minimum 7.4 GPM. This is the minimum 7.4 GPM. So as per option one, each sprinkler from the discharge area shall provide a discharge uh, flow of 7.4 GPM. So next step is that you have to see that in your design area there is no single room which has an area more than 800 square feet. So obviously no way, because in our case the design area is only 570 square feet. So we will skip this point two and move to the point three. So point three says that in room or compartments which are less than 800 square foot, uh, calculated based on delivering a minimum of 0.5 GPM per square foot over a room or the compartment using the area of the room divided by the number of sprinklers in the room. So I have two different rooms. The big one, you can see that if I can show you the room with the red boundary and the room with the yellow boundary. So thing is, if the flow rate in smaller area should be more as compared to the flow rate in bigger area, because area of the yellow is lesser than other two rooms. So as I have said that the in yellow room there are two sprinklers over an area of 212 square foot. So this yellow room has an area of 212 square foot. So the discharge in the room would be 21.1 GPM. How it would be, because this clause says that you have to multiply the area of the room or compartment with the discharge density of 0.1 GPM. So this area will give you that how much discharge would be in this whole room, which would be uh, as per calculation 21.1 GPM. So because there are two sprinklers in this yellow room, so it means to say that from one sprinkler the discharge would be around 10.6 GPM. So that's the really critical point which I'm here to clarify during this video, is that no, as per option one, sprinkler would discharge at 17.4 GPM, and as per option three, should be 10.4 GPM. But here we need to consider that this minimum required discharge from each design area sprinkler shall be greater of the following. So greater of the following means to say through one, through two, through three. Class two is not applicable, so we will choose for option one and option three. Through option one, our calculated flow rate per sprinkler is 7.4 GPM, and for option 3, it is 10.6 GPM. So that's done. You need to say we will design, or we will run the calculations in such a way that the hydraulically most disadvantaged sprinklers, these four sprinklers, shall have a K factor of 5.8, and the discharge pressure would be 9.7 psi. And in that case, each sprinkler will give you a discharge rate of 7.4 GPM. And if we run those calcs with those parameters in hand, we can be confident that our system complies NFPA 13 special approach with respect to residential sprinkler systems. So that's it done. That's the only part for this video is. So I hope you have make your concepts clear. And if you have any questions, or if you're not sure about, so you are feel free to send me an email, or you can comment on my video, and I will try to reach you to clarify your concepts. And thanks again for watching this video, and have a good one. Thank you.